I'm a reliability technician. I also do failure analysis like Todd does. And I do electrical breakdowns. And how can you figure out what happened with an electrical breakdown? I just have to come across sometimes saying, this is the end of life. Of course, management doesn't want to hear that, but sometimes you have no other route. I'm a level 1 ultrasound certification. I'm a level 1 infrared. And what does all that mean? It means I have a lot more to learn. Level 2 and level 3. I train 48 men in my plant to do ultrasound, and I oversee both programs, ultrasound and infrared. These two tools are complementary to each other. I've been in maintenance for over 30 years. I've been in every plant in South Jersey, every different industry. Right now I'm with General Mills in Vinen, and we make the soup called Progresso. So this is my first food industry I've been in, and I really like it quite well. Everything is clean. I'm going to take you on a little journey. Now this is definitely not a training session. It's more like a history session, more or less. We're going to go back into past and present maintenance with their past tools, and predictive maintenance to past and present tools, of course, infrared being the present, and the ultrasound. Now again, I'm not a ultrasound salesman, but I'm really impressed with what they do. Let's go back into preventative maintenance. Years ago, or still now, we do greasing. We check the bearings for noises, check the gearboxes for oil. We tighten nuts and bolts, make sure everything is loosened up. And we use tools to help us do this. In the old days, if you didn't see the grease, that bearing was not greased. As you can see, that is a well-greased bearing. Nowadays, it's altogether different. We also use the old screwdriver. Can anybody relate to the screwdriver listening for bearings? Yeah, that was an old test method we did before, and now we come up to a little better tool. This is the one-ear stethoscope. Great tool. Some of the mechanics have 2-ear stethoscopes like the doctors, but I prefer this solid one there. It's just good for me. Yep, I do hear something. Don't know what, but I hear it. And now they came up with a better tool. UE came up with a better tool. This is the 9000. An outside contractor came in, checked our air compressors. He had one. I said, let me play with this a little bit because I have the 9000. It's a nice tool, but it doesn't record. You can't upload or download a route. Now here's my baby right there, the 9000. I grew up on the 9000, and I train everybody on the 9000. We're going to get a better one real soon, the 15,000, but, going through corporate takes a little bit of time. 9000 is a great tool. You can record with it and download all your history to the DMS files. And there it is at work. You see this little number right there? That is the number of a route. Now, of course, this is a dry area. If it was in a wet area, that wouldn't last that long. But here we are using the 9000 at work, checking these bearings. Since we've been doing ultrasound in our plant, especially on the back end of packaging, they're running in a 98% runtime, which is really good. Our time between failures is very, very low, and I contribute that to the ultrasound gun. Then we come up with a better tool. You have the 10,000 and the 15,000. 10,000 will record, and you have a spectrum analyzer on it. And the 15,000 is even a little better tool. That's the one we're going to get. That you can have a spectrum analyzer on it, but you could also take a picture, which is really great for air leaks. When you tag an air leak, even myself, after I found it, I go back to repair it, I can't find it. It's just disappeared. Somebody took the tag off of it. Can't find where the leak is. With the 15,000, I could put that picture on the work order, and the mechanic will actually see a picture where the air leak is. So another great advantage to a tool there to help us do a better job. Now, in the old days, this is how we did our predictive maintenance. Let me look at my crystal ball and see when it's going to fail. Also, it was a great tool to get rid of management. They'd come over, you have a breakdown, they say, how long is it going to take to fix this? And I said, let me look at my crystal ball, and I'll tell you. They get pretty upset and walk away, which is good. They go back to work. But that's basically how it was done 10, 15, or 20 years ago. Today we got the best tools on the market. The infrared camera, as you can see, can detect that bad bearing. We also have the spectrum analysis, which you can see what you're hearing, which is very important. Because sometimes you really can't understand what you're hearing. But if you see it, you know you have a bad bearing. Okay, the two tools, the ultrasound gun and the infrared camera, you have to have both of them. You could do one without the other, but the two of them makes it a whole much better job. Now, training people, I get a lot of negative feedback. I don't want to do this. This is another chore. This is something else I don't want to do. So I just use the word sport, the IR. That's a visual sport. And they're thinking, what is this going on? Sport. Equipment that you can stand away from, you don't have to have any physical contact with, and you can find out if something is going wrong very easily. Ultrasound is an audio, hearing, contact sport. And they're thinking about, wow, how am I going to play a game with this? But it does change the idea a little bit. Like Todd was saying, the first presenter, I forgot his name, Cliff. Change is very hard. And so you have to get these people on board so they see the benefits of doing something different. So I put the word sport on it, and it helps out a little bit. Now, this is the works of an IR camera. It's 15 feet above me. To get there with the ultra probe, I have to get a ladder or a skyjack or something else to get me up there to do ultrasound on it. But with the infrared, I detected that this gearbox is hotter than the motor. It should be the other way around. Gone up there and checked it, and it was low on oil. Actually, we had to replace it because it had a bad seal. But infrared does work very well in maintenance plants. Steam traps. Infrared works well on steam traps. You can see that this steam trap is fully charged. It's not going anywhere. But the ultrasound proved that it was never opening. We put the ultra probe on it and listened and listened and listened and listened, and it never opened. So it was definitely bad. Again, the two of them complement each other. Now, for electrical inspections, you can't beat infrared. I personally like when I'm doing an inspection on electrical panels using the black and white scope. But with their software, you can change anything from iron rainbow to black and white to any other colors they have, but the focus. If it's not in focus, you can't do anything about that. But infrared picked up this bad fuse clip. Now, when you have some loud noises and they want you to find it with the ultra probe, this is an overhead conveyor. It's called a cableway. Squealing. I mean, it was squealing almost, you could hear a bunch of all the other noises. They said, get your ultra probe and find out which roller is giving us a trouble. If you could hear it, ultrasound is not going to help you. So this is what I did. Ultrasound starts at 20,000 cycles above the human ear. Hearing is between 20 and 18,000. As you can see, women hear higher than men, but it's the nature of the beast. So ultrasound is not going to help you there at all. Here's where IR came in. IR detected actually several bad rollers, but that was the worst one. And we were able to quiet the noise down as soon as we could, change the roller out, and everybody was happy. So two things work together, IR and ultrasound. Of course, there are limitations to ultrasound. If you could hear it, it's not working. It's got to be above the human ear. Ultra probe in the earlier stages will detect bad bearings by trending. You can see there that NASA has proved, and again, I'm not a ultrasound salesman, but NASA has proved that ultrasound will detect and keep your plant going. The ultraprobe hears the things that you can't hear. Dave, can you play that one? I stress this very much when I'm training everybody. Listen, listen, listen. Train your ears. It's very important. Dave, how about the bad one? And now, Dave, the last one. You can hear all the crackling and popping and all these little noises. And again, we don't have the 15,000 or 10,000 to see what we're listening to. All we have is the 9,000. So I have to train our mechanics to listen, and train their ear for what they're doing. And what really made me do this is once in my training session, I said, okay, we're going to go out and find the warble tone generator. So I went out to the plant and I hid it. I hid it under a piece of equipment. And I said, all right, go out there, use the gross method, find the bearing, find the warble tone generator, and bring it back. Well, the guy's out there 10, 15, 20 minutes. I'm getting a little worried. I want to know what happens. So I go out there and I'm looking for him. I found him and he said, is this it? Is this it? Is this it? And I realized that he had no idea what he's listening to or what he's listening for. So I brought them all back into the conference room, and I turned on the generator. I said, now listen to what you're going to be listening to. And they heard the warble tone generator work. They understood. They trained their ear of what they're going to listen to. I went out in the plant, and I hit it again, and 10 minutes later, one found it. So it's very important, I think, in training people to use the ultrasound on what they're going to be listening to. So I stress good bearings, bad bearings, and I go over it 10 times in the classroom. I said, let's listen to it again. Train yourself what you're listening to, because there's a lot of other noises out there that compete with ultrasound. We have a lot of tabletop plastic conveyors, and they have cog wheels that bring the conveyors around, the chain conveyors around, and you can hear them as well as you hear the bearing. So it sounds like a thump, 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 thump when the conveyor is going over the cog bearing. So they have to train themselves. I have to train them to not listen to that and just keep steady on the bearing and listen for the noises of the bearing. It's training and developing your ears. Dave, can we play that one? It's hard to hear. That is a bad bearing. This little roll right there, caused from lack of grease, I believe, was causing a popping sound. But you had to listen. You have to listen to it very hard to hear that little popping. Now with the 15 and 10 to 15,000 with the spectrum analyzer, they're going to be able to see. I think it's great. They're going to be able to see what they're hearing, and they'll detect that bad bearing, which was hard to determine. Much quicker. Now, we have to bring this over a little bit so you can play that soundtrack. This is a man putting 3 shots of grease in this motor. Try it again. I hear it. We're in the wrong frame here, but this is what he did. You heard pop, 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 pop. 3 pumps of grease in there, and he brought the decimal levels down dramatically. So you know that motor definitely needed a greasing. I could tell on any one of my bearings what bearing needs greasing by setting my alarms. Set the alarms for 8 over base, and you know you need greasing. So ultrasound keeps my plant going really longer than it would have been in the old days. very impressed with it. We also have a lot of steam traps in our kitchens. We make the soup. We have to heat the soups up. We also have a thing called a cooker, which is thermal processing that keeps all the bacteria out of the cans. We went through a survey when we first got this gun after we went to the classes, and we spent $40,000 in replacing steam traps. And this is a bad steam trap, bad one. Bad inverted bucket. Actually, that's a good one. Sorry. That's a good one. You can hear it opening and closing. Opening and closing. Heating up soups and other materials, it's important to have a good steam trap to keep that temperature rising at a quick enough pace to keep production going. How about the bad one, Dave? Right, it's open. You're right. You know, we have a lot of steam traps throughout the plant, except in the dry end. So ultrasound has really helped us find the bad ones, fix them, and keep us going in a faster rate. Now, we also have a lot of these plastic housings in our front end, in our fill lines, which is a high washdown area. So if you put the ultra probe on the plastic housing, you will hear nothing. The plastic just attenuates the sound, and you can't hear what's going on. So if you put the ultra probe in the center of the mounting bolt, you will hear what's going on in that bearing. But the fill lines haven't gotten aboard yet with the ultrasound. Okay, the ultrasound's great, a great leak detection tool. By using the gross to fine method, and I made this little triangle there, the gross is fine sweeping, and the fine is narrowing it down to just right where you want to go. You can find any leak to a pinpoint in your plant. Now, this is the gross method at work. Notice we're just using the comb there open. So we're sweeping, catching out any noises in the area. Now, if there's a leak, you're going to hear it, and you're going to be able to follow it. When you get close to it, you put the fine focusing probe on it, and you zero in on a little pinhole. Probably you can't even see it, but you'll definitely hear it with the ultra probe. Notice here's the fine method. It's a great leak method. You can record your leaks in decibels. You can download them to the software, and UE has a great reporting tool that management loves. And I love making them happy. It keeps me happy. This is it. This is their report. Now, I know that at my leaks there, at my FLRs there, there's 100 pounds of air pressure. But not to be alarming. I don't want to be an alarmist. I just want to let them know that things are going on. I changed that to 75 pounds. And the readings change a little bit also. And these are actually the findings of the decimal leaks in air. They have a row right over their side there that tells you how much air pressure you lost. They also have a place in the software to change it for your state and how much you're being charged for electricity. In my state, it's 14 cents per kilowatt hour. My state is very high on everything, highest taxes and highest auto insurance. But this is the greatest report you can, because once the repairs are made, it shows you how much money you save. So corporate loves it. You know, we're saving this much money a year. This happened to be $15,000. This is 1 month of doing it, and the next month you do it again. Finding air leaks is a never-ending battle. You can start one side of the plant, and the time you get all the way through the other side to start again, you find as many more. And it's one of the key issues that make them lose money, air leaks. Contact ultrasound. First thing you do in doing ultrasound is establish a route. 80 to 100 points is a nice size route. I like to keep my routes down to 80 points. Keeps things easier when you're advancing from bearing to bearing. You know, when you do the route the first time, you're going to go and do it 2 or 3 times, because as you go around it, you say, oh, I missed that bearing. I missed this bearing. I saw that one over there. And it's so easy to erase it and just start all over again before you read it. You write it down in the software. Once you get it right, It's there for a long time unless you change the whole structure of the plant there. So this is a nice even flow going from point 1 to point 2, and of course point 3 is over there, and it's not on, you can't see it. But anyway, I tell my mechanics, you're going to create your own routes. You want to keep a nice even flow. I've seen one go from tail end of the conveyor to the other side of the conveyor. That was the second point. Then he went up to the next bearing, and that was his third point. And he went around the conveyor to get to the fourth point. By the time he got into the middle of the run there, he is running back and forth and wasting a lot of time trying to keep everything even in his mind. I said, just work one side of the conveyors all the way around the whole system and come around to the other side, keeping a nice even flow. You write the route on a piece of paper, you tweak it, because I know you're going to find bearings when you go over it again that you didn't have there. You walk the route, tweak it again, and I stress to them, do this 2 or 3 times because I know you're going to find a bearing that you missed. It's very easy. You might miss the motor for the drive or something with the inboard or outboard side. When you're done and you know it's right, etch it on the side of the bearing there on the conveyor side. This way, anybody that's following you can run your route by following the routes and seeing the points come up on the gun. Nice even flow. 1, 2, 3, 4, 5. To keep you working your way around. All right, when you're doing the route the first time, you already established your route. You're going to shoot your route the first time. You're going to compare bearings to similar bearings under the same load. So you got bearing number 1, they'll give you 35 decibels. Bearing 2, 32. Bearing 3, 50. And bearing 4, 38. Now you notice that 35, 32, 38, they're pretty within range of 3 or 4 points of each other, decibels of each other. Bearing number 3, way over. But you don't know for sure if that's bad, but I bet on it myself. So when you establish your route, this is your first baseline. The only thing you have to go by is comparing bearing to bearings. Now the next time you run this route, you're going to compare bearing to itself. So this is what we got. Bearing 1, 2, 3, and 4. As you can see, bearing number 1 didn't change a bit. Bearing number 2 changed 2 decibels. Nothing to be alarming there. It doesn't hit your points. Bearing number 3 has risen 11 points. If you set your alarm for 8 over, you know that's hitting the alarm already. That bearing is definitely bad. And bearing number 4 didn't change at all. So when you first do the route, you compare bearing to bearing. When you do the route the second time and you establish your baseline, you're comparing the bearing to itself. And this is how you trend the bearings. This is how you keep the company rolling, because this bearing is bad and you got to get it changed to the next downtime so we can keep on rolling. Okay, in summary, I've gotten rid of my crystal ball. In short, metaphorically, the UE systems and the IR cameras are great tools. I mean, great tools for tracking the equipment for predictive and preventative maintenance. You could do them both. You can predict when a bearing is going to fail. You can see a bearing when it's going to fail. And the 2 tools keep your plant going. I mean, I can't say enough about it. Again, thank you very much.